If we were travel to the nearest Proxima Centauri star using the fastest solar probe spacecraft built by human so far, which travel at a speed of 7 lakh km per hour, it would take us 7,000 years to reach this star, which is just 4 light years away from the Earth. Proxima Centauri is in cosmic terms relatively close, being only 4.2 light years away. Scientists have discovered solar system at distances of hundreds and thousands of light years from our Earth. Just like our Earth, many exoplanets could exist, and there might even be life similar to the Earth, and perhaps intelligent life as well. If we consider the speed of light, our universe appears quite vast in size. If we are to explore other galaxies in the universe, we need to work on spacecraft and methods that can defy the principles of the universe, allowing us to travel faster than the speed of light. Scientists using Einstein's famous theory of general relativity have identified certain ways, such utilizing the concept of wormholes, through which we may be able to travel at speeds faster than that light in the vast expanse of the cosmos. Scientists utilizing Einstein's famous theory of general relativity have suggested some way that could potentially enable us to travel through the cosmos at speed faster than that speed of light. The first method among these wormholes. Before delving into this method, we need to understand the concept of space-time. Our scientists have largely comprehended space-time through Albert Einstein's theory of general relativity. According to this theory, space and time are interlinked as a mathematical model, combining the 3 dimensions of space with one temporal dimension into the 4th dimensional or 4-dimensional continuum called space-time. In similar terms, we are similar these dimensions, which we represent as the x, y, and z axis. If we add another dimension t representing time, it becomes a 4th dimensional mathematical model. Space-time is often referred fabric of space-time of the universe. To grasp it easily, consider space-time as a seed that bends or curves more as well place heavier objects on it. In this way, mass or energy bends space-time. Every object in the universe affected the space-time around it. In such cases, the heavier an object's mass, the more it distorts or curves its surrounding space-time, which we feel as an object gravitational pull. Consequently, objects with mass are always attracted towards the curved path of object with a higher mass. In our universe, massive objects like giant stars and black holes curve space-time the most, making their gravitational pulls the strongest. According to the scientists, the gravitational force of black holes is so intense that they create holes or openings in space-time, making even light unable to escape its event horizon. Einstein, along with Northern Rosen, believed that there could be several holes or openings in space-time connecting different locations in the space. Let us understand this with an example. Consider 2 separate points A and B in the space that are millions of light years apart. If we were travel to this distance between the using of traditional method, it would take millions or even billions of years. However, if we somehow manipulate space-time successfully, we could cover the distance between A and B in an incredibly short time without violating the law of physics. This shortcut route is what we call a wormhole. For a better understanding, let's try a small experiment. Imagine taking a piece of paper, which we can consider as a fabric of time. Assume point A and B are 2 locations in the space. Now let's fold the paper and connect point A and B, creating a shortcut path representing Y, a wormhole. In our universe, black holes might be connected through such wormholes. There they engulf everything around them, and nothing escapes their singularity. This concept challenges the traditional notion of distance and time, providing a potential shortcut through the vastness of space. Wormholes could be the cosmic tunnels connecting distant regions, making space travel more feasible and quicker, all without violating any physical laws. The second part of this could be connected to the white holes, which might spy out the matter injected by a black hole back into space, quite like a Big Bang in reverse. These white holes have properties entirely opposite of black holes. Some scientists believe that during the formation of our universe, many baby black holes were born, which are now interconnecting through cosmic string, and colossal black holes at the center, such as those found in the Milky Way, could be the result of such connections. It's possible that in the further using wormholes, we might travel between different galaxies and even explore other universes. However, according to the scientists, traveling through wormholes might take infinite time. Another popular way to achieve faster than light travel is warp drive technology. Warp drive technology is based on the hypothetical engine that can be travel through space at speeds faster than the speed of light. Simply put, warping means bending or warping space-time using this technology. We have already learned about we can curve or warp space-time with high amount of mass, matter or energy. Science fiction writer John Campbell and Isaac Asimov space have saw warping in their work as a way to achieve speeds faster than the speed of light. According to them, if we square the space in front of a spacecraft and expand or stretch the space behind it at this speed, we could potentially achieve speed faster than the speed of light without much effort. Let us try to understand this with an example. Imagine it's our space. On one side you have Earth and on the other side there's a galaxy located several light years away. As we start traveling in the spacecraft from Earth, let us stretch the space behind us and compress the space ahead. This way we can reach our destination in a significantly shorter time. It simplifies. Think of it like watching a ship in the ocean. When waves rise behind the ship, it moves toward easily. The lifting of water behind the ship and the pushing of water in front create a wave that propels the ship towards. Warp drive technology works similarly. The key is that we are only expanding the space behind the spacecraft and learning the contract the space ahead. Our protective bubble stays intact, that there won't be any change inside this bubble. It is important to note that we are not moving faster than or at the speed of light. Instead, we are supporting the space in front and stretching the space behind, surprising the speed of light. Now, let us explore the possibility of developing spacecraft using warp drive technology. If we take about compressing or squeezing the space, we have to discuss before that a massive amount of matter or mass can trap or compress space-time. To make warp drive technology possible, we will need at least as much mass as Jupiter. When it comes to expanding space, the biggest challenge lies there to stretch space. We will need to negative energy. Negative energy is something that works with the less energy than zero, creating anti-gravity to helping expand the space. However, the problem is that as of now, negative energy or exhaustive energy doesn't exist. So scientists hope that through the Casimir effect at a quantum level, negative energy could be obtained. While wormhole and warp drive are currently confined to science fiction, dreams can become reality sooner than later. In the next few years, wormholes and warp drive might transition from science fiction to reality. If we discover another way to travel faster than the speed of light, What are you through on the technology? Share your opinion. Let's end this discussion here, and I'll see you in the next knowledgeable video. Until then, goodbye and Jai Hind.